welcome to this episode of Night Sky News for August 2023 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next couple of weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the future of Voyager 2 after NASA recently lost, then regained communications with it. Plus, JWST has found water vapor in the zone where rocky planets form around a star. You might also have seen this JWST study popping up in your news feeds this month, claiming that these objects are not galaxies as first thought, but supermassive stars powered by dark matter. Or even this study using Gaia data to show a modified theory of gravity fits the data best, one that doesn't need any dark matter in the universe to work. So as usual, there's too much to fit into one Night Sky News, so those two research studies are going to be separate videos by themselves, so look out for those two videos coming up on my channel in the next couple of weeks. For now though, if you want to skip ahead to any specific news story that I'm going to cover, there's chapter markers down here so that you can do that. Plus any scientific research papers I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, let's start with the new moon that's happening this weekend on the 16th of August, because with no moon in the sky, it makes it a perfect time to look for the Milky Way. Combine that with the fact that in the southern hemisphere right now, it's winter, so you've got much longer nights, or combine that with the fact that it's summer here in the northern hemisphere, which is caused by the tilt of the Earth's axis, which gives the northern hemisphere that much better of a view towards the center of our galaxy, the Milky Way, so the view in the sky is that much better. So if you can, get away from light pollution this weekend and see if you can spot that glow across the sky that looks like spilt milk, giving it its name, the Milky Way, which is the combined light of millions and billions of stars so far away we can't make them all out individually. If you're in the northern hemisphere, then look towards the southwest at around midnight so that you're looking towards the center of our galaxy where there's more stars, and therefore the Milky Way will be much brighter. And if you are in a really dark sky, you should notice that it is much brighter towards that center on the southern horizon and then arcs out overhead and gets that much fainter. If you're in the southern hemisphere, then just look directly up to find the center of the Milky Way and again see it arcing out from there. While you're there, keep an eye out for shooting stars in the Perseids meteor shower that I talked about last month. The peak was last weekend on the 12th and 13th of August, but there are still going to be a few around, so keep your eyes peeled for that. Now, if you can't escape light pollution, then do not worry, because there's still things that you'll be able to spot even from the center of a city. So on the 18th and 19th of August, the crescent moon will come really close to the planet Mars in the evening just after sunset, hanging around for about an hour or so in the west before they both set. Mars will look reddish in color and should be very distinct from any stars in that area of the sky. Plus, I mean, if you're looking right after sunset, then you're going to have the glow of twilight around. So really the only things you're going to be able to see are the moon and Mars, and you shouldn't be able to confuse them for anything else. Then the weekend after next, so the 26th and 27th of August, my favorite planet, Saturn, reaches what's known as opposition, when it's in the exact opposite position in the sky from the sun, which means it's perfectly lit from our position here on Earth, meaning on that weekend it is the brightest that it ever gets in the night sky. So you are gonna want to try and spot this. Now this should be visible all night from wherever you are in the world, rising in the east after sunset, reaching its highest point in the sky around about midnight, and then setting in the west just before sunrise. The further you are from the equator, the lower in the sky it will be when it reaches its highest point. So for example, here in southern England, it'll get to about 25 degrees above the horizon. So that's around about the distance between your thumb and your little finger when you hold them out at arm's length in front of you. Saturn will appear a sort of yellowish color and will be a lot brighter than the stars surrounding it. It'll also have more of a sort of solid light to it rather than sort of like the twinkle of the stars. And that's just because, you know, you're reflecting a lot of light off Saturn's disk. It's coming from sort of like an area. And so as that light passes through the atmosphere, you know, more of it has to get disturbed to make Saturn look like it's twinkling, whereas stars are just little pinpricks of light. And so any disturbance in the atmosphere, you're going to see it, and that's what makes them twinkle. But if you're still struggling to pick it out from the stars, then don't worry, because the full moon will come very close to Saturn on the 30th and 31st of August, which you can then use as a marker point for where to look. The full moon will be very bright though, and will wash out Saturn quite a bit, but once you have spotted it, you'll know where to look on the next clear night that you have. Another trick is to take a long exposure shot using night mode on your phone to try and pick it out from the stars, and then you can use that image as like a star chart or a map of where to look. I've made a video before on my tips for astrophotography with your phone, which I'll link in the video description down below if you're interested. But back to the full moon now. On the 31st of August, we're going to have another supermoon, which is when the moon is much closer to us on its oval-shaped orbit, making the moon slightly larger and brighter in the sky. But the differences are far too subtle for your eyes to be able to pick them out. Despite that, this will still get hyped in the media, especially because this is a blue supermoon. And sadly, no, the moon won't look blue. A blue moon is the second full moon in a calendar month. A full moon happens roughly every 29.5 days as the moon orbits the Earth, and a calendar month, well, the majority of them are 30 or 31 days long. So if the timing is right, you can have a full moon right at the start of a month and right at the end of a month. Blue moons happen roughly every 33 months or 2 3/4 years, whereas supermoons are much more common and they happen maybe 3 to 4 times in a single year. However, the next blue supermoon pairing won't be until August 2032. But please remember, this doesn't mean anything. Inanimate ancient rocks do not give a shit about what we're all up to down here. Now, if you keep an eye on the moon in the next few days going into September, it will be rising in the east with Jupiter a few hours after sunset on the evening of the 4th of September. Jupiter is one of the brightest objects in the night sky after the moon and Venus, so it should be really easy to spot next to that beautiful 3/4 moon, fairly low on the horizon just after sunset, but then they'll rise higher together in the sky as the night goes on. Then by the morning of the 12th of September, the moon will be back to a crescent shape, this time a waning crescent, and be close to the brightest planet, Venus, in the east in the morning sky just before sunrise. Again, Venus, the brightest object in the night sky, so this should be a really nice thing to spot if you are an early morning riser. And while you're there, look out for the constellation of Orion rising in the east as well, which we haven't seen for a really long time over the summer, and so can only mean one thing.
Winter is coming.
All right, that's enough for looking up at the night sky. Let's come back down to Earth now and chat about what's been happening in space news in the past month. All right, let's start with a recap on telescope news. So the Euclid Space Telescope, which launched last month on the 1st of July 2023, has now reached its orbital position of L2, a gravitationally stable point in the Earth's sun system that is 1.5 million kilometers away from Earth. Once it got there, it took its first test science images in both optical and near infrared light, and they look incredible. Like really showcasing the high quality data that we can expect from Euclid as it maps out the positions and distances to over 10 billion galaxies in the universe in the next couple of years. If you want to know more about how we're going to use that map to study dark matter and dark energy, check out the video that I've made previously. I'll link it down below. Now, the community were a little bit worried towards the end of July when sort of like the first light images were taken, where the telescope wasn't focused yet. It was just sort of like testing everything, turning everything on, but there was clearly light that was leaking onto the detector from somewhere, and they eventually figured out that there must have been some sort of like crack or hole in the spacecraft hull of some sort that was actually letting in sunlight onto the detector. So we were a little bit worried about whether Euclid was going to be able to be used at all at one point. But thankfully, ESA have managed to figure out a workaround. Essentially, it only affects the telescope's detectors if the telescope is at a certain angle to the sun. And as long as they only use the telescope at the angles that it doesn't affect it, then everything is absolutely fine. So it makes operations a bit more complex, but nothing that ESA can't handle. So I'm excited for it to start taking proper science data for the survey, and then for that survey data to be released in a few years' time. Let's stick with another pretty picture, because this month an international team of astronomers released this incredible image taken by the James Webb Space Telescope, JWST, of the iconic ring Nebula, made famous really by the Hubble Space Telescope, but also beloved by stargazers because its iconic ring shape is also visible, you know, even with like a small 3-inch amateur telescope. You can find it yourself in the constellation of Lyra if you fancy having a go at spotting it. Now, the Ring Nebula is the remnant of a star a bit bigger than the sun that has lived, died, and gone supernova around about 4,000 years ago, so throwing off its outer layers of hydrogen, which are then lit by the leftover glowing hot core of the star in the center. Now, it's this material that's thrown off that enriches the gas around the dead star with heavier elements, so that the next generation of star with its planetary system can form out of that enriched gas and form things like rocky planets with all the ingredients for life, which is why this team, led by Michael Barlow of UCL, applied to use JWST to study the molecules present in great detail using JWST's spectroscopic instrument. Now, the team is still analyzing all of that much more complex data, but for now, they've just released this incredible image of the Ring Nebula in infrared light. So yes, it's a false color image where the colors are used to highlight the scientific information that you wouldn't otherwise be able to see with your eyes if it was just a black and white image showing infrared light detected here and not here. Now, the team didn't release any information on sort of the color choices they actually made in this image, as far as I know, but from digging through all the information in that JWST proposal of this project, I'm guessing that one of the filter images they proposed for was colored purple, and then this other one here green. So then you can highlight the cooler regions around the outskirts where you detect mostly longer infrared wavelengths, and then the hotter regions in the center where you detect mostly shorter infrared wavelengths. So just a pretty picture for now, but I'm really looking forward to this analysis being published in the future with this more complex data so that we can learn things like how do these heavier molecules survive in this environment and how are they distributed by the supernova. And on to another pretty picture from JWST now of the El Gordo cluster of galaxies, famous for its interesting shaped gravitational lenses, the so-called Thin One and the Fish Hook. Now, these are distant galaxies whose light has been bent as it travels along the curved space caused by the mass of the galaxy cluster in the foreground acting like a lens. Now, this image was released alongside 4 research papers from the JWST Pearls team who applied for this image to be taken. The first from Fry and collaborators using the lenses to estimate the total mass of the foreground galaxy cluster El Gordo. The second paper from Kamieniski and collaborators using JWST to peer through the dust in the Fish Hook lensed galaxy to work out how many stars are forming in this distant galaxy 10.6 billion light years away. The third from Diego and collaborators catalogues newly found lensed galaxies spotted with JWST but missed by Hubble, and reported the discovery of a possible single star that is in the perfect alignment for its light to get brightened by the lens so that we can spot it. Similar to the Earendel star, if you're familiar. If you're not, again, I've made a video on that before if you're interested, and I'll link it down in the description below. And finally, the fourth paper from Carleton and collaborators finding ultra-faint galaxies in the El Gordo cluster image, which as a whole is still not very well understood. So lots of interesting science going on off the back of this very beautiful cluster image, and I'll link all those research papers down below if you want to give them a read. But for now, I want to focus on this JWST study by Pelotti and collaborators, which has claimed to have found water vapor in a proto-planetary disk, a disk of material around a very young star from which planets will eventually clump together out of the material in the disk and form. Now, these discoveries were part of a big survey with JWST to study many different proto-planetary disks, but in this new study, they're focusing on the PDS-70 system, which has both an inner proto-planetary disk and an outer proto-planetary disk, separated by a gap of 8 billion kilometers wide, where we found 2 gas giant planets, one that's 3 times more massive than Jupiter and the other that's 7 times more massive than Jupiter. The star itself is only 5.4 million years old. Compare that to the sun's roughly 5 billion years old, and this star is incredibly young and most likely still forming planets, which was why it was so exciting to see this claim of water vapor in the disk's inner system that is still forming planets. It's the first time that's ever been done, and it's been made possible thanks to JWST. So what Perotti and collaborators have done here is use the MIRI instrument on board JWST, which is sensitive to much longer infrared wavelengths that aren't blocked by dust, the heavier elements that make up the protoplanetary disk that the planets are going to form from. And they've used MIRI in its integral field spectroscopy mode. And what that means is that at every pixel on the detector, you take the light and split it through a prism to get a spectrum, a trace of how much light you receive at each wavelength. So what you can then do with that data is compare, say, what does the spectrum look like in this part of the image where you've got the inner protoplanetary disk versus the spectrum in this part of the image where you've got the outer protoplanetary disk. Because handily different molecules, so things like water, H2O, or carbon dioxide, CO2, they leave their own unique fingerprint on light that lets us know that they're there. So what happens is those molecules absorb light from the star and then re-emit it. They glow at a very specific wavelength, which is unique to that molecule. So then if you look at the spectrum, that trace of light of how much light each wavelength you receive, you see these bumps at very specific wavelengths, which we can then identify as being caused by certain molecules. So that's exactly what you've got here in this plot. The blue line shows the MIRI spectrum of the inner disk of PDS-70. And hopefully you can see that when you zoom in on this incredibly detailed spectrum into these little areas, you have those telltale bumps, those fingerprints that have been left on the light that say that water is here. Which means that any rocky planets forming in that inner protoplanetary disk are going to have access to water as they form, which is incredibly exciting for a number of reasons. I mean, yes, we've discovered water vapor, we detected water vapor in protoplanetary disks before, but never this close in the inner regions around a star or in a system that we know has already formed planets like PDS-70. It's thanks to JWST that's made this discovery possible in the first place. But second of all, and why it's especially exciting, is because this inner disk extends to about 160 million kilometers away from its star. The Earth orbits the Sun at an average distance of about 150 million kilometers away. So what we're seeing here in PDS-70 could be very similar conditions to how the Earth formed. And by studying it, it could help us work out how did the Earth get its water, because the leading idea for a very long time has been that the inner solar system had no water while the Earth was forming, and that no protoplanetary disk does either, because UV light breaks apart water molecules. It splits H2O into a hydrogen and an OH molecule. And we've never seen any water vapor close in a protoplanetary disk before. Instead, the leading idea has been that, the outer solar system had all of the water and that it condensed into ice and was brought to the inner solar system by comets. Those comets then impacted with the Earth, transporting their water to us, which was then protected from breaking apart by the ultraviolet light because of the Earth's atmosphere. But perhaps there could have been water vapor in the inner solar system as Earth was forming, like we're seeing here in PDS-70 for the first time thanks to JWST. But the thing is, this result was one of the big puzzles to Perotti and collaborators, because they then had to explain, well, how do you get water vapor so close into a very young, volatile star that's throwing off a lot of UV that should be breaking these water molecules apart, but apparently isn't. And so one of their ideas was that there was lots of dust in this protoplanetary disk, so a lot of heavier molecules that were shielding the water vapor from a lot of the UV from the star. A hypothesis that was actually backed up by the detection of carbon dioxide, CO2, in the spectrum as well, another molecule that also breaks apart under UV light. The next steps here are to take an image of the PDS-70 system with the NIRCam detector on board JWST. It'll be the highest resolution image we've ever got of PDS-70. Maybe we'll we'll get another direct image detection of an exoplanet when we do that, who knows, but also to use the near-spec detector on board JWST, which will give us a spectrum at lower wavelengths where there'll be different molecular signatures present, different bumps to say different molecules are here in that different wavelength range. Once that analysis does come out and the results gets published, you know that I'll be covering them right here on my channel, so make sure you subscribe so you don't miss out. And finally, let's talk about Voyager 2, because NASA gave us all a bit of a scare this month when they temporarily lost contact with it because of the wrong command that was sent. As a reminder, Voyager 2 launched way back in 1979, visiting Jupiter, Saturn, Uranus, and Neptune. The only spacecraft to have ever visited Uranus and Neptune, and the only reason we have these images of them at all. After those visits, it just kept on going to the far reaches of the solar system, and in 2018, it officially left the solar system when it crossed what's known as the heliopause, the protective shell of particles that are burped up by the sun, what's known as the solar wind, and then it entered interstellar space. I've actually covered this in a night Sky News from the very early days of this channel for those who remember it, but how we know that Voyager 2 actually left the solar system is because of two of its many science detectors that it has on board. One to detect the solar wind particles, the particles that are burped up by the sun and, you know, sort of create this like heliopause shield around it. And then the other detector to detect interstellar cosmic rays that we assume are coming from supernova that get filtered out a little bit by the heliopause. And in 2018, those detectors on Voyager 2 pinged back the data to show the solar wind particles dropping off and the cosmic ray detections going up. Since then, Voyager 2 has been traveling yet further away from the sun at around about 56,000 kilometers per hour, and at the time of filming is around about 20 billion kilometers from the sun. That's about 134 times the Earth-Sun distance. It takes light 18.5 hours to travel that far from Earth to Voyager. So communicating with a spacecraft that is that far away is incredibly complex, especially because you have to be very careful with which direction you send your signal to that spacecraft. Because if you're ever so slightly off, then the error in how much you're off just gets bigger and bigger and bigger the further away you go, and you just end up completely missing the spacecraft. The Deep Space Network is what NASA uses to communicate with its spacecraft and get the data back from them as well. There's 3 sites across the world with many radio antennae at each to cover, you know, all directions at any time of the day. So there's one in California in the USA, one in Madrid in Spain, and one in Canberra in Australia. So then as the Earth rotates on its axis, or as also the Earth goes around the sun as well, you end up switching which antenna, which site you're using to communicate with a given spacecraft. So it's a huge operation, and one of my favorite things is to look at the website that shows you the current status of the Deep Space Network. But on the 21st of July, NASA announced that a series of planned commands accidentally caused the antennae on Voyager 2 to point 2 degrees away from Earth, meaning it was sending all of its science data in completely the wrong direction of missing Earth, and that any of our commands that we sent to it were being missed by the antenna because they were far too weak of a signal to be picked up in a different direction, you know, by the time they'd traveled 20 billion kilometers away. Now, this was especially frustrating because we weren't getting any of the scientific data from the instruments that were still on board Voyager 2, like, for example, the cosmic ray detector that helped us work out that Voyager 2 had left the solar system, because NASA estimates that in around about 2026, 2027, Voyager 2 is going to completely run out of power. It won't be able to power its scientific instruments to actually collect data, and it won't have enough power to send that data back through its antennae to Earth so that we can receive it. So, I mean, it's gonna be a very sad day when its mission comes to an end, but it's especially frustrating now that we're missing out on getting data from those scientific instruments while we still can, because it's not gonna be here forever. No one was especially worried about Voyager 2 though, thanks to a failsafe that was coded into the system way back in the 70s that every few months or so gets Voyager 2 to completely reset its position so that the antennae is definitely pointing back towards Earth. So we were all very grateful for a 50-year-old piece of code this month, and it meant that, you know, maybe we'd have to wait till the 15th of October when the next reset of the antenna was, hours for us to be able to get data again. So that meant that, you know, worst case scenario, we were going to lose about 3 months worth of scientific data, which from a scientific perspective is the worst case scenario, but from an engineering perspective is probably the best case scenario. Thankfully, though, at the start of August, NASA tried one last thing before giving up, essentially shouting at the spacecraft, sending out an incredibly loud signal, one with a very large amplitude, so that by the time it made the 20 billion kilometer journey to Voyager and it had dispersed slightly, it was still strong enough of a signal so that the antennae pointing in slightly the wrong direction could still pick it up. NASA used the DSS-43 antennae in Canberra in Australia to send the shout. Then they had to wait 37 hours to know if it had worked. 18.5 hours for the signal to travel from Earth to Voyager 2 to tell it to actually, you know, like turn its antennae back to Earth. And then another 18.5 hours for that first data packet then sent by Voyager back to Earth to travel from Voyager to Earth. So the team sent the command and then essentially had their fingers crossed for over a day and a half, finally receiving a signal back at 12:29 on the 4th of August to let them know that all was well. NASA is now receiving science data from Voyager 2 again after only losing about 2 weeks worth of data. So a pretty good outcome, all things considered. Maybe this was just the universe's way of preparing us for when the power finally goes out on Voyager 2 in around about 3 years' time. All right, that's it for Night Sky News for this month. As always, if you snap any pictures of the night sky, send them my way over on social media. But also, if you see any space or astronomy related news stories that you want me to explain in a future Night Sky News episode, then send them my way as well. Look out for those 2 videos that are coming up on my channel in the next couple of weeks as well. The first on those supermassive dark matter stars that people have claimed to have found in JWST, and the other one on the evidence for modified gravity from Gaia data, a theory of gravity that doesn't need any dark matter in the universe to work. But until I see you next time, everybody, happy stargazing. Image is sort of like a star chart, or a star chart. Looks so odd, just like the claw. Why can't you bend nicely, fingers? Why can't you be more dainty? Trying to show off my nail polish, that's the thing. Elements that then go into making things like rocky planets and all the life that lives here as well. I don't know what this was. I was just like, yeah, life. That's this thing. With an inner proto-planetary disk and an outer Frodo, Mr. Frodo. And then another to detect interstellar. It's like Tom Selleck entered it in my mind. Just like, surprise. Has both an inner proto-planetary disk and an outer proto-planetary disk. So I'll just say that 3 times faster. Proto-planetary disk. People don't come for the bloopers, right? They come for the space. They stay for the bloopers maybe, but they just don't get their money this week. It'll be fine.